Okay, so electric vehicles are pretty much everywhere now. But there's this one huge question that always comes up, especially if you live somewhere that gets a real winter. How do they actually handle the cold? Well, today, we're going to dig into the data, everything from lab tests to the icy roads of Alaska, to find the unfrozen truth about EV performance when the temperature really drops.
So let's just ask the question straight up. Do electric cars actually work in the winter? You know, it's the #1 cause of range anxiety, that little voice in your head worrying you'll run out of juice and get stranded. And when it's freezing outside, yeah, that anxiety gets turned up to 11.
All right, let's start with a number that might honestly shock you. 54%. Lab tests show that in certain situations, your EV's range can plummet by as much as 54%. We're talking city driving at minus 10 degrees Celsius, which is about 14 Fahrenheit. I mean, that is a huge chunk of your driving distance just gone. So where on earth is all that energy going?
Well, it turns out there are two main culprits here. Think of them as a pair of energy thieves, working together to steal your precious miles. And if you want to fight back, you've got to understand how they operate. Okay, so thief #1 is the battery itself. When it gets cold, the chemistry inside your lithium-ion battery gets, well, sluggish. The ions just can't move around as fast. Then there's thief #2, and this one is a biggie, the cost of comfort. See, a gas car creates tons of waste heat from the engine to keep you warm. An EV doesn't have that. It has to use its main battery to heat up the cabin for you and to keep its own battery pack from getting too cold.
And check this out. This chart visualizes that sluggish chemistry perfectly. On the left, you see the battery's total available power just dropping as it gets colder. But on the right, look at that. Its internal resistance, which is basically how hard the battery has to work to push power out, it just skyrockets. You're asking it to work so much harder for every little bit of energy. It's kind of like trying to swim through molasses instead of water.
And this chart just perfectly shows you that cost of comfort we were talking about. Look at the bottom bar at a nice 25 Celsius. See? No gray bar for heating. But now look at the top bar at a freezing minus 10 degrees. That gray bar for the HVAC system is enormous. It means in slow city driving, you can literally use more energy just to stay warm than you do to actually move the car. It's wild.
So if heating is such a huge energy hog, it makes sense that the kind of heater your car has would make a massive difference, right? And that leads us right into a really key piece of tech in the EV world, the battle of the heaters.
So the older, simpler tech is called a resistive heater. The easiest way to think about it is it's just like a toaster. It runs electricity through something that resists it, and boom, you get heat. It works, it gets hot fast, but it's a brute force approach. It just devours electricity.
But the smarter solution is a heat pump. Now this is much more clever. Instead of just making heat from scratch, it works like your air conditioner, but in reverse. It actually finds and gathers heat from the cold outside air and pumps it into the car. It's just a way more efficient way to get warm.
And look, the data doesn't lie. In these tests, the red line is that old-school toaster-style heater. The blue line, that's the heat pump. At every single temperature, the blue line is way, way lower. That gap between the lines, that's pure energy savings that go directly back into your driving range. So what's the bottom line? How much of a difference are we talking about here? Well, according to these tests, in moderately cold weather, right around freezing, just having a heat pump can improve your range by up to 15%. That is a pretty serious chunk of miles you get to keep. All right, so lab tests are one thing. But what happens in the messy, unpredictable real world, with snow and wind and traffic? For that, we're going to head to two places that definitely know a thing or two about winter: the crazy cold of Alaska and the chilly roads of Norway. First up, Fairbanks, Alaska. Researchers there tracked a bunch of EVs driving in some of the most brutal conditions you can imagine, with temperatures dropping below minus 39 degrees. And that's that magic number where Celsius and Fahrenheit are exactly the same, and it is just painfully cold.
And the results from the real world? Whoa, they were stark. Forget the lab numbers for a second. This is what drivers actually saw. On average, their car's efficiency was cut by a staggering 58% between summer and the dead of winter. It just confirms that, yep, in the real world, extreme cold has an extreme impact.
But not all cars and not all winters are the same. This data is from a recent test in Norway, where it's cold but not Alaska cold. And what's fascinating here is the huge difference between cars. The Polestar 3, look at that, a clear winner, losing only about 5% of its range. But then check out the Tesla Model 3.
It has the biggest official range on paper, but it lost nearly a quarter of it in the cold. It just proves that the car's engineering, like having a super efficient heat pump and good battery insulation, matters a ton. So, knowing all of this, what can you actually do about it? Because it's not just about the car, it's about how you use it. So here it is, your simple playbook, with 4 key moves you can make to fight back against those energy thieves. Okay, first and most important tip of all, precondition. It just means you warm up the battery and the cabin before you unplug while you're still using power from the wall, not your battery. Huge difference. Number 2, use your heated seats and heated steering wheel. Seriously, heating your body directly is way more efficient than trying to heat up all the air in the car. Third, if you have to park outside in the freezing cold for a long time, if you can, leave the car plugged in. It lets the car sip grid power to keep its own battery warm and happy. And finally, number 4 is a mental one. Just adjust your expectations. Know that on the absolute coldest days, your range might take a big hit. Planning for that is the single best way to kill that range anxiety.
So the reality right now is that, yeah, winter is a challenge for EVs, but it's a challenge you can manage with the right tech and the right habits, which kind of leave us with one big question to think about. As batteries keep getting better, as heating systems get smarter, and as fast chargers become as common as gas stations, will this entire conversation just become a relic? Will winter range anxiety one day be a thing of the past? Something to think about. Thanks for tuning in.